This lesson is going to be about light waves and sound waves. Light waves, the waves that we can see, and sound waves, the waves that we can hear, actually come from two different types of waves. Light waves are from what we call a transverse wave. These are waves that move up and down. This makes each particle that experiences the wave also move up and down. Sound waves are longitudinal. They're waves that move side to side. These are waves that are vibrations. The fact that as the wave passes through, particles vibrate allows us to hear sound. Light waves actually have the ability to move through all types of mediums. A medium is a material, so they can move through solids, liquids, and gases. The solids or liquids have to be transparent. What that means is we have to be able to see through them. So for instance, if we wanted to see light through a liquid, we would maybe use a liquid like water, where we could definitely see light through it. And what's really important about light waves is they can travel through empty space, and that's how the sun's light gets to us in the form of radiation, which is movement through waves. Sound waves can also move through all different types, but there must be a medium for them to move through. The speed of a light wave is definitely faster than a sound wave, and sound waves then, of course, are slower than light waves. Amplitude means how intense or strong a wave is. So light waves have a higher amplitude. They give us a higher amplitude of a light wave would give us a brighter light, whereas a higher amplitude of a sound wave would give us a greater volume. So having a high amplitude of either of these has a different implication for how we experience the wave. Frequency in a light wave is going to be higher than sound waves. So different frequencies are going to allow us to see different colors of light. The highest frequency light is the lowest, is the shortest wavelength. So those are going to be like our blues, purples, or violets, indigo. And our lowest frequency waves are going to have the highest wavelength, and those are going to be like our reds and oranges. Sound waves have a lower frequency than light waves, but frequency is what changes the pitch of a sound wave. Wavelength for light waves is lower or shorter than sound waves. So again, different wavelength yields a different color. So long wavelengths are going to give us a color like red or warm colors. A short wavelength is going to be a high frequency that's going to give us colors like purple, blue, indigo, violet. Okay, and then sound waves are higher than light waves in terms of their wavelength. Really what that means is that the wavelength is longer than a light wave. Light waves can in fact move through empty vacuums like space. They do not need a medium to pass through, but as we said when I talked about mediums of travel, sound waves need material to move through, so they cannot move through a vacuum like space. Okay, and just to give you an idea of what amplitude means for power and sound, the more power that is put into a sound, the greater the amplitude is going to be. So if you take a look at this chart, you can see that the louder the sounds are, the greater the power is, the greater the decibel reading, which is the dB. So like a medium loud rock concert is going to have way more power and more sound and strength and amplitude than someone whispering.